Corporate finance practice problem using OneNote. Present value, different discount rates. We're going to do that with a side-by-side comparison. Don't leave profits solely to chance. Instead, use corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if you would like to, we're in this tab on the left-hand side. We're in the practice problems, and then down in the 919 present value, different discount rates side-by-side section. Closing this out with the icon on the left-hand side. Also note, if you have access to OneNote, you might want to check out this immersive reader, which will actually go through text files and go through and give you translation options to other languages and even read it through in terms of the English or other languages with the translation. May not be as useful for this practice problem, but we do have transcripts that we add to this resource from time to time, and you can use that to basically translate if you would like to and even hear the information in the translated format. So we're going to have our information up top on the left-hand side. We're going to go through the calculation in a few different ways in the blue areas down below. This will be a present value calculation. We're going to be comparing side by side the difference of interest rates. We'll do the calculation a few different ways. One, with the mathematical formula. Two, with an Excel type of calculation, which would be similar to a financial calculator type of calculation. And then we'll take a look at it with tables as well, often used in book problems. Information, we're going to say in 30 years, we have an amount of the 100,000. So we're imagining a situation where we're going to get 100,000 in 30 years. What would it be in terms of today's dollars? Well, to do that, we would have to get some kind of discount rate. The discount rate typically taking into consideration time value of money, possibly inflation. In other words, what could we do with that money if we had it now? And then think about basically reversing that out, right? If I had the money today, I can do something with it or invest it. So I want to take into consideration the time value of money, and you have to take into consideration those factors basically to figure a discount rate which could be appropriate. This is a guess, and we could use multiple rates. You could start to experiment with the rates that would be used, which we'll start with here. And we're saying, well, what if it was 12%? What if it was 5%? We'll do a side-by-side comparison. We'll start it out with this formula, the mathematical formula today, and we'll compare it to money today of the 20,000. So you can imagine a situation, possibly a prize situation, you winning something or something like that, and they say, we'll give you 100,000 in 30 years, or we'll give you 20,000 today, that type of scenario. And obviously, if you need the money today, then it wouldn't be too difficult of a question. You say, well, I need it now. But if you don't need it right now, then you might say, hey, maybe I'll wait 30 years if it's going to be a significantly more amount. So that's going to be the scenario. So we're going to bring then this 100,000 back to the present day. The 20,000 is already in the present day. You don't need to do anything for that. We need to compare it from the same thing to the same thing, apples to apples, as they say, by bringing the 100,000 back to the present. We'll do that first mathematically. Present value equals the future value times 1 over 1 plus r to the n. The future value being, in this case, the 100,000 we will receive in the future. R then being the rate, which will be the differential factor of 12% or 5%. N being the number of periods, that being 30, in this case, periods being years. So if we break this calculation, I'm going to break it down into like a table type of format. Useful tool to use. We basically want the numerator and the denominator in the far right column, and then any other kind of calculations I need, like this bottom calculation, I'll pull into the inner column. So for example, for A and B scenario, we have the 100,000, 100,000. That's going to be the future value, same for each. Then we've got the 1 plus r to the n. That's going to be the denominator here, the bottom part, which I'm going to pull into the inner column here and here, and do our calculations there. So 1, that's going to be this 1, plus the rate, that's the differential factor, which is going to be either 12 or 5%. And then if we add those up, we get the 112% or 105%. Note, when you're doing these calculations, you got to be thinking about, am I recording this in terms of decimals or percents as you enter this into a calculator? And then we're going to say we need to take that to the 30 periods, to the n, to the 30 periods. So that's going to be, caret 30. So once again, remember that if you're using a financial calculator or some type of calculator, you need to take it to the power of 30. So that's 112, 105 to the power of 30. which is going to give us the 29.95992, noting that this is going to be rounded out to this decimal, rounded out to this decimal over here. Note that if you're using some kind of test question, they may actually force you to round it out to so many decimals, like 3 decimals, 2 decimals, 4 decimals, and they might use that to see if you're following the directions or using some particular format of calculation. So be careful with instructions on things like test questions. Probably wouldn't matter in practice because those rounding deviations would not be material enough, most likely, to change a decision-making process, but can be utilized in test questions. And then the present value, if we take the final calculation, is the future value, the 100,000 here, divided by the denominator, which we came to here. That's going to be the 333.7.79 and the 23,137.74 that we have on this comparison. So we can see the differences between the 12 and the 5%. If we compare either of those to the 20,000, if we got today, if we consider our discount rate, if we're estimating the discount rate to be 12%, then this one would come out below, right? We wouldn't want option A. But if we consider the discount rate to be only 5%, then we might say that this 23,000 comes out higher. So we may then choose the 100,000 in 30 years. We may still not choose it. We might say, hey, I need the money now, so I'd rather have it now. But if we could hold on to the money and we're saying, hey, you know, the 100,000 is going to be worth more based on the discount rate that we used, and I don't need it right now, you know, I'm going to let the money, you know, grow at that point, then possibly we might choose then option B. If we were to figure out the factor in a table, this is going to be this number divided by the 100,000. And this is how you can think about how they come up with the factoring tables, which we'll take a look at later, tables often used for practice problems. Let's do it again. We're going to do the same type of calculation. This time we're going to just consider if we used a financial calculator or say Excel type of calculator. And we've basically seen this in prior presentations, so I won't do the calculation for both of these and say what would happen in Excel. We do have this problem in Excel, so you can take a look at it in Excel and run the calculation, but we could see these two. We could see the same two for A and B, the net result. Also note that if you're using Excel, the next question you might have, if you're comparing these two and you're saying, okay, well, what would be the interest rate, which would be the break-even kind of interest rate, meaning when would these two options be the same? When would it be this discount rate taking the present value of the 100,000 to equal the present day dollar amount of 20,000, which could be a fair question to ask. It might help you with your determination process. So instead of just randomly picking interest rates here that you think might be applicable, then why don't we determine the interest rate which would make these two options even, basically the break-even point. Now in Excel, they have a system that you can use called GoalSeek. So once again, I recommend using Excel, taking a look at the practice problem in Excel, and we'll use that tool of GoalSeek to kind of figure out the rate, which in this case would be the 5.5113, which would basically be that break-even rate. So we'll continue on here. The next one is the tables. So we can use the same kind of thing with the calculation of the tables, 100,000, 100,000. Then we want to look at the tables for the 12%, 30 years, and 5%, 30 years. So if we look at this, we're going to say, all right, table, make sure you're picking up the correct table, present value of 1, not an annuity. 12% here at the 30 years. 30 years is way down here. 12%, 30 years, 0.0334. So that's where this 0.0334 is coming from here. And that once again gives us to that 3340. And then we got the 100,000 at the 5%. So 30 years, 5%, 5%, 30 years would be down here, 0.1741. So hold on a sec, 5%, 30 years at 5%. So 5%, 30 years is 0.2314, 0.2314. And if we multiply these out, 100,000 times 0.0334, 3340, 100,000 times 0.23414 is the 23,140. Notice that these two amounts may be slightly different than these two amounts, 23,137.74, for example, and so this one, for example, is 23,137.74. 137.74 versus 140. And that's because we've rounded the tables, or the tables have been rounded to 4 digits, which are not quite as exact, meaning if I go back up top, these are actually the decimals a little bit further out, 0.03338 and 0.231377 if we take it out further than 4 digits. Here, 0.0334 and 0.2314. The tables are typically fine for normal decision-making purposes, but once again, if using test questions, they can use that difference in order to restrict like multiple choice answers and try to force you to use something like the tables, possibly trying to get the financial calculator either out of your hands or make it obsolete by making the answer key more specific, taking into consideration rounding.